Just please remind me whenever I do any session. If I forget to record, just remind me. No?
Okay.
Sometimes, yeah, I'll forget to record it. Next is tank capacity. So for tank capacity, what we have to do? Generally, before going to tank capacity, we'll just run through the pump room. Okay, and this is, for example, our pump room. We have different tank, right? This is fire tank. Fire tank 1. Fire tank 2. Then we have raw water. Lastly, treated water. Like this we have. So whenever first water goes to your fire tank, then it goes to overflow, go to fire tank 2. Okay, then overflow to raw water tank. Then it goes to the filtration unit. This is WTP, water treatment plant. Then it comes back to the treated tank. Okay, from there, here is the outlet, and here is the pump we have. Is it clear up to here?
Clear. Yes, yes.
So generally, we have tank. If we divide what tank capacity, we have underground tank, and we have overhead tank.
Overhead tank.
Okay. Underground tank is divided into, basically for plumbing point of view, we have raw water tank and treated water tank. Right. So here I'm just not taking anything for domestic flushing. You can do it, right? You can take 60%. What you can do is 135 I have taken total. Okay. What you can do is you can take 90 domestic, 45 flushing. Like this you can do, and you can arrive it. Okay. And that also we will do in commercial, so that you can understand the details. Just we are learning this sequence. Okay. So treated water tank, what we will do, raw water tank is, this is 1.5 day storage. Okay. Treated 1 day storage. Up to here clear? Any doubt?
Okay, this is clear.
Rajiv, Dilip, Deepak, Siddhamesh, all are clear? Okay.
Yes, it's clear.
Okay. So I'll just erase this drawing part. So now, raw water tank, we have calculated 159 something, right? 56 cubic meter. That is per day. If you remember, it is per day, right? Water requirement per day. So
what we have arrived now, sir, 156, that is domestic and flushing.
Flushing, both.
Both is it?
Yeah. If you want to further divide that, you can do here, previous part. Okay, here you have divided, you should have divided that. Water requirement, for example.
90, 45 like that.
Yeah, 90, 45 we can
That
take
is for
it.
domestic,
Yes. If you want, we can do that. You want like this, or just I'll carry on?
Yes, sir, but in UG tank.
Okay, better we'll do to avoid a lot of confusion. Okay,
Yes.
we will do that.
For designing tank, UG tank, we have to consider only 90 liters, no, sir?
Yes,
95.
yes. Fine. So here 90 liters domestic and 45 liter. It is per person per day. Huh? Per person per day is equal to flushing. So now tell me water requirement, domestic water requirement is how much? Flushing water requirement is how much? Domestic water requirement per day 90 multiply with number of people 115.
103,950 liters.
103,950.
50.
Okay, liters. And for flushing water requirement per day 45, 50% will come roughly,
It's
right?
around, yes,
Yeah, it will be around 52 or something. Yeah.
yes, 51,975 liters.
So it will be how much? 104
So this
cubic,
52.
and it is 52.
Two.
I'll just write down this as 1 cubic is equal to 1000 liters, right? Let me save this. Let me see in the notes what you have considered. Okay. Okay, we have even considered the same thing. We have also considered the same thing in the notes. Can you see my screen?
Yes, sir.
Yeah, I have considered the same thing. So round off. Okay. For visitor, I have taken 10 liters. Either way, anyway, you are achieving more. It is well and good, not a problem, right?
Right, sir.
So go ahead with this 102 and 51. 104 and 52, right? Next, tank capacity. Step number 4, tank capacity. So for tank capacity, underground tank, we will go raw water tank and treated water tank. Raw water tank, I'll take 1.5 day storage. Treated, I'll take 1 day storage. But in notes, it is mentioned, it will be mentioned, just let me show you. Yeah, can you see my screen?
Yes, sir.
Yes.
Yes.
Yeah. Here you see, don't see here, just I want to show you here. See, in case of all other building, apartment, hotel, hospital and commercial, the capacity of underground tank and overhead tank may be taken as 1.5 days. Okay. And half a day demand. That means 2 days storage basically. So whereas raw water and treated water are stored in the separate UG tank, the combined storage capacity should be of 1.5 day. Okay. And overhead tank, you can go for 50%
Storage.
half the storage. Okay, here it is mentioned. In case of overhead tank is provided, you can take this So what I'll just summarize here. So you see here, I have taken total 2-day storage you need to keep. Okay. If you're keeping underground tank, 1.5 day storage, which is a combination of both treated and
raw water.
raw water. And OST,
0.5 day.
0.5 day storage. Okay. So total should be 2 day storage minimum.
2 days. Yes, sir.
Okay. This you can do it. So what we have done here generally, 2 day storage. For what I have done is 1 day storage I have taken for raw water, and treated water I have taken 66.6%, and overhead tank I have taken 33.3, which is minimum, right? You can see here. In case of combined storage is provided, it may be taken as 66.6% UGT and 33% overhead tank of 1 day requirement.
Right.
Right?
Yeah.
So I have taken overhead tank 33.3 minimum. Why minimum? I can take 50 also, because if you keep the tank capacity more in overhead, it will have a structural load on the building. Okay. For that reason, try to give it as minimum as possible. So minimum is 33. Is it clear now? Any confusion?
No, clear.
Okay.
Clear, sir.
What about Deepak? Rajiv?
Clear, sir.
Okay. Okay. So same thing I'll take 1 day for raw water. Okay. And treated water I'll take 66, means 0.66 storage. Okay. So 1 day storage, this raw water means your domestic water, right?
Yes, sir.
So domestic water will be how much? We got 104, right?
104
Cubic meter. So 0.6 will be how much? I'll just calculate. 0.66 multiply with 104. I'm getting 68 point something. So I'll take 69 or 70. Yeah, 69 or 70 I can take. Yeah. 70 cubic meter. Next is your overhead tank. Overhead tank is 0.33 day storage. Which will be, I'll just subtract this, from 34 or 35 cubic meter I'll take. Is it clear?
Yes, sir. Yes.
Okay. So these are the tank storage for underground. So next is total requirement we have calculated per day is how much? We have calculated, if we combine both domestic and flushing, how much it was coming? 104 and 52, right? This was domestic and this was flushing,
Right, sir.
right? So it will be how much? 651.
56.
So now we'll find the STP capacity. Same step number 4, part 1 is this. Okay, part 2 is STP capacity. STP capacity is 90 to 95% we can take. 90 to 95% of 1 day storage. So how much will come? 90 or 9, take 90. Okay, this is the range, you take it 90. So how much you're getting? This value 90. So I'll just subtract 16. So I'll get 140. Just calculate how much you're getting. 90% of this value.
140.4.
140. So I've taken 140.
Yes.
Clear up to here? Any doubt?
Yeah.
Clear, sir.
Okay. Okay. So next step is what? Step 5. So now you can calculate the flow. So how you will calculate the flow? Any idea? Okay. You have treated tank 70. Treated tank is how much? 70 cubic per day, right?
Right. 70
Yeah.
cubic per day.
Yeah. If I want to make it per hour, so what I have to do? Divide by 24. So I'll get cubic meter per hour, right?
Right, sir.
Yeah, just divide that. 70 divided by 24. I'm getting 2.91.
2.9.
2.91 I'm getting. Okay. So 2.91, I can take it 3. I'll just share the screen. It will be given in the notes itself. 1 minute. Yeah. Yeah, up to here clear. This is also done. Domestic tank and treated tank. Okay, flushing tank, if you want to find, you can find out what requirement. Treated tank, overhead tank. Next is pump flow. Step 5 is pump flow and velocity. Velocity, this is the range we need to give. So treated tank, how much flow you are getting? 3 cubic meter per hour. But my pump will not run for all the hours, right? For 24 hours, if run,
Yes, sir.
this much flow is required. But my pump will not run for all the hours, right? Maximum, I will allow my pump to run 4 to 6 hours a day, which means 1/4, right? 1/4 time, if you reduce the pump power, you should increase 4 times the flow. Getting my point?
और एक बार रिपीट कीजिए.
हाँ, अगर तुमको very simple 20 hours if you run, you want a flow 3 hours. Here mathematical little bit confusion is there. Okay, just don't understand in mathematical way, you'll get confused. Okay, if I run this 24 hour, I will run in 3 cubic meter. This is the
3
flow
cubic meter per
hour. Okay, this is the flow. If I will run the pump for 6 hours, you will divide here 4, here 4. No, that is wrong. So here this should be multiplied here. So 12. If same thing, for example, if you're running 24 hour, your pump flow should be
3
cubic meter per hour,
Right.
which is less. If I want to run the same, deliver the same thing in 6 hours, so my pump flow should be more or less. Obviously more, right?
Yes.
अगर तुमको 24 hour में if your pump is running, yeah,
100%.
yeah, I told in starting, don't understand in the mathematical way. Okay, here logical way you need to understand. Okay, if I'm reducing the pump power for 4 times, okay, so I need to increase the flow 4 times.
Right, sir. Right.
Yes.
Right. So I'll get 12 cubic meter per hour.
per hour.
Rajiv, Dilip, all are getting?
Yes, sir.
Okay. So if you get cubic meter per hour, can you convert this into liter per minute or something? Any conversion can you make? So how to make a conversion? 12 cubic meter per hour. So how to make in LPM? So 12 cubic meters. So convert into liters. So we got liter per hour, convert into minutes, divided by 60. 200, near about 1200 LPM. In 1 minute, 200 liter will flow, right?
Right.
All are clear? The conversion, this conversion you can do it. It is
Yes.
very easy.
एक मिनट,
Next is, हाँ,
थोड़ा बैक आएगा सर, थोड़ा रेटिंग कर रहा था. ठीक है, हाँ एक मिनट. No, please, okay.
yes.
Okay.
Okay. Next, velocity, you know, 1.5 to 2 you will take. Okay. Generally, this is velocity for very higher end. If you increase the velocity, so what is the impact? Just for example, one person will tell, I will go for velocity. Understand the concept here. Huh? One person will tell, I will go with the velocity 1.5. Another person will tell the velocity is, I'll take 2 meter per second. So what impact both will have? So here the formula is Q is equal to AV. Okay. My flow is constant. Okay. So my flow is constant, but velocity is inversely proportional to area. Area means pi by 4 d square. Okay. So if I increase the velocity, so what happen? If I increase the velocity, so what happen? My dia will decrease, right? If I decrease the velocity, my dia will increase. Clear?
एक बार रिपीट कीजिए. Can you again this velocity, this last part?
See, this formula is Q is equal to AV. Okay, where Q is equal to flow